Hi everyone, welcome to the new video. So today we will discuss again the answer of the scenario based question. Again I'm picking two questions. So without further ado, let's start. So the question is database migration with near zero downtime. So a production MySQL database store approximately 25 TB of customer data and receive nearly 8,000 write operation per second. So this company wants to migrate from self-managed MySQL running on EC2 to Amazon Aurora MySQL, and the migration must not result in data loss, and the maintenance window is limited to 5 minutes. So explain your complete migration plan, which AWS migration services would you use, how would you migrate schema, continuous data changes and application connection, how would you validate data consistency, and how would your rollback procedure look like if the new database experience performance issue after production traffic is switched. So before discussing this answer, I would like to tell that for migrating the database, there is a service called AWS database migration already in Amazon. So basically we can create a task in this database migration service. According to the task, we can start copying the whole data and also replicating the change data. Like if something is getting added while you are copying to the old database, it will also get copied to the new database or the whatever new service you are going to use now. So that is one thing in database migration service, and we can explore more about this service in more in coming videos. But of course I'll cover this briefly by demoing it in the AWS console. So there is this feature which I wanted to tell. Of course, and the question was that how to migrate database, the schema and everything. Again, there is one what you say, a conversion tool, schema conversion tool, which we need to install, and there is a full document for it about it. I'll give it in GitHub repo, in the description box. You can read it, give a read, and we can use that for schema conversion or schema, copying the schema and everything. And then let's see. So first of all, our goal is that MySQL database was an EC2, which is the database size is 25 TB, and nearly 8,000 write requests is coming per second. So first of all, we need to create a target database. We need to create a MySQL cluster, because it's like Amazon Aurora is like a cluster, whole cluster under which the read replicas and everything will be running. So we will create everything. Then the schema conversion we will use, and we need to install everything. I will give the documentation, please do give a read. It will help in copying the schema object about table, primary key, foreign key indexes, stored procedures and everything. So Aurora now has the same database structure. Okay, now we will initiate the data load, like copying the data using the AWS database migration service, and we'll use full load. We'll create a task inside that, and we'll select full load plus the continuous data replication. So full load plus change data capture. So this we have to select, so that whatever old data is getting copied, that is fine, but whatever new data is coming this course of time, that is also getting copied. So once that is done, once we'll see that everything source and target stay organized, we'll see that what our application lag is when it becomes 0, that everything is replicated. Now we have only the maintenance window of 5 minutes. Then we will stop or write transaction. Okay, once the replication lag becomes 0, no pending transaction remain. Now we will do actual cutover. So mostly in our application properties file, we give that the URL of the DB server that we are going to use. There we need to update everything, update the DNS and everything. And accordingly, when we update this DNS and the credentials and everywhere, so we'll update that from older one to new one, the Amazon Aurora one. And then we'll do the validation like the row count and everything. We will already take this row count and everything in before doing the cutover and all. We will have the actual row count and everything in place, so that we can match those row count after cutover. And then we'll do the monitoring. If everything is fine, then our migration is complete. But if something is failing, if high CPU, slow queries or everything, then again we have to stop the application writes, and again we will have to change the DB endpoint. We will have to revert to the uh, revert to the previous one, and user can again and again we can investigate it. So this is how the high level steps. But I will try to demo this by in the AWS console, basically the database migration service. Next question is that we have to Jenkins to Azure DevOps migration. So we currently have nearly 700 pipelines, 100 of shared libraries, self-hosted Linux and Windows agents, SonarQube integration, Artifactory, Kubernetes deployment, and management has decided to migrate. So like without any existing development team continue releasing software without any interruption. So what will be our migration approach, secrets and deployment strategy, CI/CD pipeline, and how decommissioning will happen. So for that, first of all, we need to understand that in the existing 700 pipelines plus the shared library, what all analyze it, the existing pipeline, like we need to group app codes of Java, then the .NET, Node, Python, Docker. When we group it accordingly, we'll create the Azure DevOps project, we'll create the repositories, we'll give the permissions and everything. After creating this, we'll configure the agents, because in Azure we can have self-hosted Linux and Windows agents that will create. It's advisable to use AKS cluster, so that nothing is down. Okay, agents are not down. We'll configure the connection so that our Kubernetes is able to cluster is able to connect to the SonarQube, the Artifactory, Azure Keyword, all the service connections in place. Then we'll start converting the Jenkins files using Azure YAML, and basically the stages. Okay, the stages like build, checkout, unit test, every stages will be replicated, and we can use AI also for that. For the similar kind of repos, we can use similar type of templates and the AI. So this can be done. Then we'll convert the shared library into YAML templates, and we can, like, it's similar, and we can use those YAML templates. Import secret into keyword. Then we'll first test the pipeline in non-production. If that is done, we'll proceed to higher environments. And if once the production deployment is done to that pipeline, then we'll decommission the older Jenkins file of that particular repo. So both the things will run in parallel until and unless one successful production deployment is not done from our Azure pipeline. Once that is done, we'll start disabling the Jenkins pipeline. So this will be our approach, and in nearly there should be a target that in 1 week we should try to complete 10 repos for the starting. Then we can increase 50, and then we can go for more. When we have automations in place, we can go for more repos, and in 3 to 4 months we are able to complete everything. That should be our target, and accordingly to achieve that target we need to work. So yeah, that's all. So that's all for today's video. I hope it's helpful. Please let me know your views in the comment section. Till then, take care. Bye.